practice question time. So I know these solubility graphs look really intimidating and really confusing. Here's the trick. Make each line a separate color. This will help you focus on each of the lines separately. It'll cut down on the chances that you'll make a mistake or get confused, and it'll be easier to talk about and think about the answers as the yellow line, the red line, the blue line, and the green line, as opposed to thinking about using the full chemical formulas for each of these substances. So take a minute right now, pause this video, and color code your graph on your note page so it looks like mine. So now that your solubility graph is color coded like mine, it'll be a lot easier to talk about these questions and answers. So number 1 on your page says, which two substances have the same solubility at 80 degrees Celsius? So what I'm going to do is I'm going to look at 80 degrees Celsius, and I'm going to travel up this line until I hit 2 solubility lines at once. Boom, right here. I'm hitting both the red line and the yellow line at one spot here at 80 degrees Celsius. So for number 1, my answer is NaClO3, which is our yellow line. I'll highlight it in yellow so we can keep track of our answers here. And our red line, which is KNO3. And again, I am just going to highlight KNO3 in red to help us keep track of our answers here. Okay, so the next question says, which substance is least soluble at 60 degrees Celsius? So I'm going to look over here at 60 degrees, and I'm going to travel up from this line until I hit the first solubility curve. Boom! I hit NaCl first. That means that NaCl has the lowest solubility than any other substance on this graph. So under number 2, I am going to write NaCl, and again, I'm going to highlight it in green to help us organize our thoughts. Done. Okay. Number 3 says, at what temperature does KBr, that's the blue line, have a solubility of 110 grams per 100 milliliters of water? So I am going to look at 110 right here on our y-axis because we're looking at solubility of 110 grams per 100 milliliters of water. And I'm going to travel over from this line until I hit that blue solubility line. Boom, here it is. So I am at 105 degrees Celsius. So at 105 degrees Celsius, KBr, the blue line, has a solubility of 110 grams. So I am going to write that right here, 105 degrees Celsius. So at this point, if you're feeling pretty confident about solubility graphs, I recommend pausing this video, doing number 4 and 5 on your own, and then coming back to the slide video to check your answers. Everybody else, let's move on to number 4. Is a solution of 160 grams of NaClO3 saturated, unsaturated, or supersaturated at 20 degrees Celsius? So we are going to be looking at the yellow line, and we are going to start at 160 over here on the y-axis, and we are going to travel over until we hit the line for 20 degrees Celsius. So that is right here. So 20 degrees Celsius and 160 grams per 100 milliliters of water. Boom, right here. So this point is above the yellow line, and we know if we are above the yellow line, we are going to be super saturated. So number 4 is super saturated. And lastly, number 5 is the trickiest one. So number 5 is a solution of 20 grams of NaCl3, so 20 grams, and we're looking at the green line here, saturated at 60 degrees. That's the first part. So 20 grams, and we're going to go over until 60 degrees, boom, right here. We are underneath the green line for NaCl, so that means we are unsaturated. The second part of the question says, how much NaCl would you need to add to saturate the solution at this temperature, right? So we're at 20 grams at 60 degrees, and we have to get up to 40 grams, because with 40 grams at 60 degrees, the solution is saturated. So 20 and 40. 20, 40. That means we have to add 20 more grams to saturate the solution. So 20 more grams to saturate the solution.